Hello everyone, I hope you guys are doing good. So today we'll be discussing another problem of a blind 75 series, and the problem of the day would be problem 238, product of array except self. So here we have been given an integer array nums, and we have to return an array answer such that answer I is equal to the product of all the elements of nums except nums I. The product of any prefix or suffix of nums is guaranteed to fit a 32-bit integer, and this has been given to us in the problem. It's also been given that we must write an algorithm that runs in O of n time and without using the division operation. So these are the two main challenges in front of us before solving this problem. So in the given problem, let's say, for example, we have been given our input array nums, which is 1, 2, 3, 4. And we have to return an output array in which each element has, or each element stores, a value of the product of complete array except itself. So let's say for I is equal to 0, the value that our array would hold would be 2 into 3 into 4, and that would be 24. Similarly, for value 1, it would be 1 into 3 into 4, and that would be 12. Similarly, for I equals to 2, it would be 8, and I equals to 3, it would be 6. So you must be thinking that how can we do this without even using a division operator? Because the first thing, or the first idea, the brute force idea that we get is to simply move forward, complete the product, store the product. Let's say I could have moved forward and completed the product in one go. And let's say the complete product would be 24. And then I would have again moved throughout the array and just have divided each element and store those values in the index of our output. But as we know, we cannot do this. So what we need to know is how can we approach this problem? So for this problem, we'll have two variables to help us solving this problem. Those will be a prefix variable and a postfix variable. So you must be thinking what this prefix and postfix do. As we know, the main condition is we have to do this in big O of n time. So to complete this in big O of n time, we can move from left to right like twice or thrice, but we cannot have nested loops. So for that, what we'll do is to calculate for, let's say, I equals to 2, to calculate the product of the array except the element at I equals to 2, what we'll do is we'll use the value of prefix. Prefix is the numbers before 3, and the values of postfix. Postfix are the product of numbers after 3. So the prefix here would be 1 into 2, and the postfix here would be 4. And if we are able to multiply the prefix and the postfix, we are good to go, and we can just store that value in our output array. Here you can see that's 8. So how will we be approaching this problem? So what we'll do is we'll first create, let's say, a result array, and we'll initialize it as 1 for each number present in our nums array. So initializing it to 1 because we are dealing with product, so it would help us keeping track of the prefix and postfix while multiplying. And What the next step would be is we'll initialize our prefix as 1 and we'll start traversing the nums from left to right. And what we'll do is when we are at a position I, what we have to do is store the value of prefix of this element. So that's why we have started with 1. So here we will just put 1. After that, what we'll do is we'll multiply our prefix. Let me just rewrite our array nums 1, 2, 3, and 4. Yes. So after putting the prefix for index 0, what we'll do is we'll multiply our prefix with the current value at index 0. That's 1. So our new prefix value would be 1. Now we'll go to index 0 and we'll say the new prefix value or the value of the prefix of I equals to 2 is 1. And as we can see, it's true. It's only 1. Now what we'll do is we'll update our prefix, and what we'll do, we'll multiply the current value of prefix with the current value of nums I, and it would be 2. And then we'll similarly go to the next index and update the value in our result array, and it would be 2. Similarly, we'll go to the last index, we'll update our prefix to 2 times 3, it would be 6, and we'll just put the value of 6 over here. Now what we have is, we have the value of prefix of each of the element over here. So let's say for I at I equals to 2, we have 2, that is 1 times 2. Similarly, at I equals to 3, we have 1 times 2 times 2 times 3, that's 6. So we are done with calculating the prefixes. Now what we have to do is calculate the postfixes. So for that, what we need to do, we just need to traverse our nums array from left to right. So for postfix, we have to do left to right. For prefix, we have to do right to left. Also, for the postfix, we'll be initializing it to 1 for the similar reasons as we are doing product or multiplying stuff, and it will help us keep track of the product. And now when we'll start moving, what we'll do is similarly what we did while moving left to right, we'll just repeat it, but now from right to left. This will help us and we'll keep on updating our result array, which currently looks like this. So now what we'll do is for postfix 1, we'll be at the last index. We'll say the postfix is 1, so we'll just multiply it by 1 and let it be right here. Now we have to update our postfix. So what we'll do is we'll multiply our postfix with 4, as this was the last element of nums. Now the value of our postfix is 4, and we'll come at index 2, which is 3, and we'll just multiply the value of its prefix with the value of the postfix, and we know the value that will come up to here will be 2 times 8. 2 times 4, that would be 8. Similarly, for I equals to 1, we'll multiply its prefix with postfix. And what would be its postfix? It would just be 4 times 3. That's 12. So here we'll be having 12. Similarly, we'll update the postfix to 24, multiply 1 by 24, and here we have a solution. So let's now talk about the code for this problem. So we'll move on step by step. As I said, we'll first have a result array, or if you want to keep it like answer as it's asked in the question, you can keep it like answer. And what we'll do is we'll initialize 1 for every num in our array nums or the input array. We have to initialize the prefix equals to 1, And then we'll start traversing the array from left to right. So for I in range len of nums, remember in Python, the last element is not included, so length of nums, not nums minus 1. Then what we have to do is we have to update the value in our result array, and what it would be is similar, just multiplied by prefix. Then also we have to update our prefix. It would just be a product of prefix and the current value of num psi. And just by doing this, we'll be done with calculating the prefixes of each of the element. So what now we have to do is we have to declare the postfix as 1. Then we have to start moving from right to left. So I'll say for I in range len nums minus 1. The first element's always including while declaring the range. So len nums minus 1 till the last element with a break of 1. And then we'll update our si. And it would be just a product of postfix and resi. Similarly, we'll be updating our postfix, which would be the product of postfix and num psi, similar to the first calculation of prefixes, just going from right to left this time. And we'll just return our result. Let's check our solution. As we can see, this is a pretty efficient solution. And as given in the problem, we have completed this solution in big O of n time. And talking about the space complexity of the solution is also big O of n. So thank you guys for watching this video. I hope you guys understood the concept.